Hello and welcome to today's lesson looking at the insulation required practical, which is part of the advanced energy topic in GCSE Separate Science Physics. So in today's lesson we're going to try to understand how material thickness affects that material's insulating properties. So if we're successful and we learn in today's lesson, we should be able to define what thermal insulation is, describe how different factors affect the effectiveness of thermal insulation, and carry out an investigation to examine how those factors affect a thermal insulator, which links into the following part of the GCSE Separate Science and Combined Science topic of energy transfers in a system, which links into this particular part of the specification, and finally required practical activity 2, investigating the effectiveness of different materials as thermal insulators and the factors that may affect the thermal insulation properties of a material. So in this particular investigation we're trying to work out the effect of material thickness on the thermal insulating properties of a material. So if we're successful in this particular required practical, we can work out the effect the thickness of a material has on how good a material can insulate. So which links into this particular required practical on the physics course. So in this particular practical we are going to need a 250ml beaker, a thermometer, a piece of cardboard, scissors, a stopwatch, newspaper and rubber bands. So we will use the kettle to boil water and pour 300ml of this hot water into a 400ml beaker. We'll then use a piece of cardboard as a lid for the beaker. The cardboard must have a hole for the thermometer. Insert a thermometer into the hole in the cardboard lid so its bulb is in the hot water. We'll then record the temperature of the water and start the stopwatch. We'll then record the temperature of the water every 5 minutes for 25 minutes, and after this has been carried out we'll calculate the temperature change from the start of the investigation. We'll then repeat the investigation for different layers of insulation around the beaker. So one layer is one wrapping of the newspaper around the beaker and secure that newspaper insulation with elastic bands. So in this investigation you are varying the thickness of insulation. So in this investigation the newspaper will act as a thermal insulator. Now what we're going to have is we're going to have different sections of 10 layers of insulation labelled. So this particular amount of newspaper is 10 layers of insulation. This one is 20 layers of insulation. This one is 30 layers of insulation. This one is 40 layers of insulation, and this one is 50 layers of insulation. Now it's probably best that if you're working in a class you would only do one selection of layers of insulation and then you'll share it as a class to get a full set of results because of the length of time it takes to gain your results in this investigation. So you will then carry out this investigation also with no insulation around a beaker. This is a control beaker, and this is to observe the effect of the insulation compared to if there was no insulation around the beaker. So you'll boil a kettle to gain hot water, which will probably be carried out by your class teacher. You'll get one 400ml beaker. You then wrap your selected value of insulation layer thickness around the beaker. Ensure it's done tightly so there's no air gaps or air pockets between the beaker and the insulation layer. You then wrap your selected value and secure that with secure insulation with an elastic band. You then place the beaker on a heat-proof mat. Now the heat-proof mat will act as a source of insulating material for the bottom of the beaker. Now if this wasn't done, this would be a source of error in the investigation. So you'll only carry this out for one value of thickness only, but in theory there should be 6 different values you would obtain when you share your results in the class. One with the control with no insulation, one with 10 layers, 120, 130, 140 and 150. You then retrieve a thermometer. Now the thermometer has a resolution of 1 degree Celsius. This means that temperature cannot have any decimal places recorded because the number of decimal places recorded is decided by the resolution of the thermometer. If the thermometer cannot read decimal places, you do not include decimal places in your answer. You then retrieve a lid for your beaker. You'd retrieve a stopwatch. Now the stopwatch has a resolution of 0.01 seconds. This means that the time should be recorded to 0.01 seconds or to 2 decimal places because you record your results to the same resolution as that of the measuring device. So with the hot water from the kettle you'll fill your beaker up to 300ml using the markings on the inside of the beaker to achieve this. You'll place your lid on your beaker. Now this is to prevent heat loss from the top of the beaker via evaporation. Now again, if this wasn't done, this would be another source of error in the investigation because in this practical we're looking at the effect of heat loss via conduction, not via evaporation. You then record the temperature of the beaker once the temperature is reading the right temperature. The thermometer is reading the right temperature. So the thermometer should read the right temperature when it's immersed in hot water for about 2 minutes as it's had chance to gain thermal equilibrium. You then using the stopwatch to measure the time, record the thermometer of your beaker every 5 minutes. You then carry this out until you've received it for 25 minutes. So this means you'll have a value for 0 minutes, 5 minutes, 10 minutes, 15 minutes, 20 minutes, and 25 minutes. So your interval is 5 minutes, but your range is from 0 to 25 minutes. Now, once you've done this, collect your results from the other groups who've carried out the experiment with the different insulation layer values. Now, just to clarify, when you're taking your thermometer measurement, please ensure you stand in parallel. Otherwise, you will gain a parallax error on your experimental results. Now, you could also reduce this by repeating the investigation multiple times and calculating an average. You then record your results in the following table. Note you'd have the number of insulation layers as one column, then the temperature after 0, 5, 10, 15, 20 and 25 minutes, and then an overall temperature change. You then produce a graph with the time on the x-axis and the thermometer of the beaker, the temperature of the beaker on the y-axis. This will produce two lines on the graph, one for your insulated beaker and one for your control beaker, and if possible draw them in different colours, as such like that. So you can see there and carries out with the data you've collected yourself. And then on a second graph, draw a bar chart with the number of insulation layers on the x-axis and the temperature change on the y-axis, and this should be done for all the data collected in this investigation, not just your own, so all the data you've collated. So in theory you will gain a results like this, and you can draw a conclusion about how the number of layers of insulation will affect the temperature change and therefore the effectiveness of thermal insulation of the material. So let's just summarize what we've learned. Energy cannot be transferred usefully, stored or dissipated. So it can be transferred usefully, stored or dissipated, but cannot be created or destroyed. You should be able to describe with examples when there are energy transfers in a closed system that there are no net change to the total energy. You should be able to describe with examples how in all systems energy can be dissipated in their changes, so it's stored in less useful ways, and we describe it as waste energy. Now, thermal insulation is material which reduces heat transfer in a substance. The best thermal insulators are materials which slow down heat transfer a lot. Most insulators work as they have a low thermal conductivity, as it reduces the transfer of energy by conduction across the material. So you should be able to explain ways of reducing unwanted energy transfers, so for example through lubrication or through the use of thermal insulation, and understand that the higher the thermal conductivity of a material, the higher the rate of energy transfer by conduction across that material. And you should also be able to describe how the rate of cooling of a building is affected by the thickness and thermal conductivity of its walls. So if we're successful in today's lesson, we should be able to define what thermal insulation is, describe how different factors affect the effectiveness of thermal insulation, and we can carry out an investigation to examine how factors affect a thermal insulator. I hope you've enjoyed today's lesson looking at the insulation required practical, which is the energy topic of GCSE Separate Science Physics. Thank you very much for listening to today's lesson, and have a lovely day.